So in this next example, again, we want to prove if the triangles are similar. So if so, we want to write a similarity statement and then find the value of just x, not y. So I already noticed that in the small triangle and the large triangle, angle Q is shared by both. So I wrote angle Q is congruent to angle Q because of the reflexive property of congruence. Next thing is I noticed that we have a pair of parallel segments, so parallel, parallel, and I highlighted a transversal here. And from what I highlighted, I see the letter F. So I know that the angles, like in the corners of the F, here and here, have to be congruent because they're corresponding angles. So angle QRS is congruent to angle P because of the corresponding angles postulate. You could have also said that angle QSR and angle T are congruent because of the corresponding angles postulate. So I know that the triangles have to be similar by angle, angle. So I'm going to name the first triangle, the smaller one, QRS. And the larger one then would be QPT. So that is the work necessary for proving the triangles similar by angle, angle. What I want to do now though is find the value of x. So I have to again set up a proportion because corresponding sides in similar figures are proportional. And what I like to do first is write out the extended proportion with the side lengths, just recording the first letters from each triangle, the last two letters from each triangle, the first and the last letters, so I know what corresponds. And then I'm going to go into the diagram and copy down what numbers and expressions that I have. So QR and QP literally have nothing there. So they're not going to be super helpful for this proportion. I know that RS, though, is equal to 12, and PT is equal to 16. QS is the letter X, and then QT is this entire segment that is made up of X and 5. A part of it is X, a part of it is 5. So I want to do part plus part equals the whole. So I want to do some segment addition postulate. So QT is this entire segment. So I want to add X and 5 together. What we could do here is simplify the 12 over 16. You could directly cross multiply if you want to, but I noticed 12 and 16 have a common factor of 4 that I could remove. And I'm going to then cross multiply. So my 1 cross product is going to get me 4x. The other cross product, I'm multiplying 3 times the quantity x plus 5. So I have to distribute. And then when I solve, subtract 3x from both sides, I get that x is equal to 15. For the last one, again, we're not finding the value of y, just x, but I first want to determine if the triangles are similar. So in order to do that, I need two pairs of angles congruent. So the first thing that jumps out to me are these right angles, angle V and angle RTS. Both have right angle marks on them. So I know that they have to be congruent because all right angles are congruent. Then the next thing that I notice is the small triangle and the large triangle both overlap or have angle S inside of them. They share angle S. So angle S would be congruent to angle S by the reflexive property of congruence. So I've proven the two pairs of angles congruent. I'm ready to say that the triangles are similar by angle, angle. So I might start with a smaller triangle. STR would be similar to SVQ. Again, following the same order of arc marks. So that proves the triangle similar. What I want to do now is figure out the value of x. So what I'm going to do is use my similarity statement again to write the extended proportion with the order of the letters. So again, I did first two letters, last two letters, first and last letters to figure out what sides correspond. I'm going to then go into the picture and write down the numbers and the expressions that I have for all these side lengths. So ST is 12, SV is x plus 12, because remember from S to V we have a part x and a part 12, so we have to add them together. TR is 3, VQ is 5, and I don't have any information about SR or SQ, so that's not going to be helpful to me when I'm setting up my proportion. I can't simplify 3/5 anymore, so I'm just going to go ahead and cross multiply. So my one cross product, I'm going to get 60. The other cross product, I'm going to multiply 3 by x plus 12. I'm going to distribute. I'm going to subtract 36 from both sides. Divide by 3. We get x is equal to 8.